Good evening, everyone. My name is Harald, and I'm the coach for team iHaus. For the past few months, our team has been working on an app that will serve as an assistant for energy management of smart homes. With assistant, we mean an intelligent system that can work independently with minimal user input. Thomas and Lisa will tell you more about that. First, let me shortly introduce the contributors to our project. And I need a clicker. Yeah. Thank you. Starting with our customer, iHaus, represented by Ralph, Anton, and Andrei. Thank you for your assistance throughout the project. It's been easy and a pleasure working with you. Continuing with our management, consisting of the project leader, Jan, whom I would like to thank on behalf of the team for helping focus on the right direction, and myself as a coach. And concluding with our developers who have invested their time and energy and skill night and day for making this project a success. Now I would like to hand over to Lisa. She'll tell you more about our project.
Hello everybody, let's go into detail. Technologies like solar systems, storage batteries and e-mobility drastically changed the way we use electrical power in our living environment. Modern homes and technologies give us the opportunity to efficiently coordinate the processes of charging cars, control parts of our houses, or washing clothing to our personal preferences. Despite all available technologies, we have to take the external factors such as weather and traffic information into account. Individually, they offer high potential in achieving something great, but to manage all those factors in one resulting microgrid becomes a complex matter. Our vision is iHaus Mode, the answer to the complexity, to help the customer easily control their personal microgrid. The app will be in charge of managing your home energy to your personal preferences, and therefore we created 4 different modes. First, the Eco Mode, where the house will be managed, the energy will be managed in an environment-friendly way. For example, to choose power generated by solar energy instead of non-renewable energy. Second, the Vacation Mode. Here the house will be fully automated and manage your energy consumptions when the user is on vacation. Third, the High Availability Mode. Here this mode guarantees instant access to any devices. For example, the car will start charging as soon as it's plugged in. And last but not least, the Money Saving Mode. This mode will try to save money whenever it's possible. For example, it will compare and choose the cheapest power provider. Okay. And on the other side, we have our non-functional requirements, such as usability. This is our main goal, because energy management is so complex, and therefore we provide the user intuitive guidelines and an easy-to-use interface. The extensibility is also important. To extend our app is simple in terms of adding new modes or device types that can be managed. And the security is an important point for our application. I can hear someone's coming. Let's see who it is.
It's great to be home again. Let's connect to my house. Oh, did my wife change the password? Ah, now it is working. So guys, who wants to join me for a party tonight?
Oh, not me. Sorry, I have an early meeting tomorrow.
Hey, why are you not tired? We just got back from our 6 weeks vacation.
Maybe I will join you later.
Okay, then. See you guys.
So, I have an early meeting tomorrow. Maybe I should check if the Tesla is loaded. Oh, it's not. 7%. Okay, I could change to high availability mode.
Hey, no, change it to Eco Mode instead. We need to save the environment.
But are you sure the Tesla is going to be charged?
Yes, for sure.
Okay, then I will change it.
Eco mode activated.
Okay, now we had a look. Okay, now that looked simple. Now we will go into details about our subsystem decomposition again. This time we will take a closer look at our brain architecture, which we will dive into now. As an inspiration, we used the blackboard pattern for our brain architecture, and we called it the gray board. So what's gray board like and how does it work? The gray board is basically a table with decision factors and time slots. And we have different input knowledge sources, which we called agents. The agents persist data on the gray board. We have two different kinds of agents. We have device agents and we have contextual agents. The device agents are responsible for devices like the Tesla car, the house battery, and the washing machine. And the contextual agents are responsible for services like the weather service and the calendar service. In the first step, the agents retrieve the current status from the devices and processes them. In the next step, they persist the data on the gray board. For example, the Tesla agent writes on the board that it's connected but not charging. The battery agent writes on the board that the current status of the house battery. And the energy agent writes the currently selected energy source on the board. Furthermore, we have also the weather forecast and the calendar events and the current user location on the board. Now let's take a closer look at one of the agents. An agent can have different behaviors depending on which mode he is in. The behavior is described through a decision tree. In this example, we see the eco mode decision tree. In the first row, we see that the car is connected and the energy source is solar power, so we put the car to charging. In the second row, it's the same scenario, so we also charge the car. In the third row, we see that the car is connected, but this time we have the battery as energy source, so we also charge the car. In the last row, we see that the car is connected, but this time we don't have solar power, nor do we have battery power as energy source, and as the user doesn't have any events scheduled for this time slot, we don't charge the car. Now, in order to find a window where we can charge the car without interruption, we annotated decision outcomes with awesomeness factors. Those awesomeness factors are later used in the sliding analyzer to find the window, the most awesome window for charging the car. For that, we add up the awesomeness factors within the window and check where the highest awesomeness is. In this case, it's the first 4 hours. This result is then transferred to the result table and then later back-propagated to the gray board where it updates the Tesla. Now, the last missing piece is now to actually put the devices to charging. For this, we get the energy status from the devices, from the gray board and from the iHaus, and compare them with each other. If they are equal, we don't have to do anything. If they are not equal, we generate a feedback option, which we will later on send to the iHaus mode app, where we ask the user if he wants to charge the car. The user selects yes, he wants to charge the car, so it's converted to an action element and sent back to the car, where the car starts charging. So that's so much to our architecture. Now we will continue with the second part of our live demo. Enjoy.
Tesla is charging.
So the Tesla is now charging. There's another one. Should the washing machine start?
Yes, I need my clothes to be washed.
Okay, then I would.
Washing machine started.
So now it's loaded and started.
I think with those two, eco mode will be too expensive. Maybe we change to money saving mode?
Na, Geizhals.
What?
Nothing. Okay, I can change to money saving mode.
Money saving mode activated.
Okay, cool. So I go now to my meeting. Do you guys want to join me for some breakfast?
Yeah, sure, let's go.
Cool.
Yeah, let's go.
Okay, we hope you enjoyed our presentation. Now we'll tell you something about the challenges in our project. For the design of our brain, we evaluated different concepts and tried to develop a unique architecture with help of modern machine learning technology. On base of our non-functional requirement usability, it was a challenge to create a checklist as part of the vacation mode. We didn't want to see the user randomly walk through the house, but rather be presented with activities in a useful order. And for the energy provider, we integrated a future model, which based on an energy price change per hour. Currently in Germany, this model is not applicable, and therefore we mocked it. What is the status so far? We implemented our 4 awesome modes. And to make the management much simpler, we integrated third-party services and devices into our app. This includes the Tesla, the BSH washing machine, and the iHaus battery. We made the energy management fully automated, but the user still has the chance to accept or decline certain actions with our feedback option. Furthermore, we included additionally information, such as weather prediction, user location, and the real-time energy consumption. The real-time data is not checked yet because we mocked it. We mocked the energy price. And what about the future? Maybe there will be more modes, and the energy sharing will be a big point in the future of iHaus. Thanks for your attention, and if you have any questions, feel free to ask. The team will be there for you.
Does our customer have any questions?
Congratulations. The client accepts the project. Really, I have to give you a great compliment. I've done this project, I think, the 7th time now, and it was one of, I would say, the best experience with the team I had in this practicum. And I'm not only saying that because I have to, because it was really fun working with you. And I think all of you were very engaged, and I hope to see some of you back at iHaus soon. So my first question would be if any of you would have thought to accomplish all of that in that time. None, right? So I guess that goes back to Professor Berger's team effort. So great job on that. The second is, where do you think should we take the project further? Not only with different modes, but what was your inspiration, like what smart homes and smart energy distribution can do in the future?
The energy sharing will be a big point, but for now it's uneconomic because there are legal framework which does not allow to share energy with someone else without paying transit charges.
So, okay.
But that's maybe a big point.
Yeah. So let's make sure we all work, especially in Germany, to get better possibilities to do that in the future. Thank you.